Welcome to our session on identifying risks associated with artificial intelligence. We are going to explore how to spot dangers in artificial intelligence systems, who the potential attackers are, the specific types of harm these systems can cause, and the unique hurdles we face in managing these risks. As an audit professional, mastering this concept is incredibly valuable for your day-to-day work. It allows you to confidently assess whether a company's new artificial intelligence tool is actually safe for daily operations or if it hides unseen dangers. You will be able to guide leadership on whether to adopt a specific technology by accurately mapping out what could go wrong before a financial or reputational disaster occurs. Let us start by looking at how we integrate artificial intelligence risk identification into an organization. This process is not a one-time event. It must be woven directly into the company's overall risk management program. You have to continuously look for risks on an annual basis. Whenever systems change, or when you hire new vendors, when you do this, you must account for the unique characteristics of artificial intelligence, including new types of attackers and unique operational challenges. A major part of this involves addressing human psychology. People naturally tend to trust machines too much. There is an assumption that an artificial intelligence solution is inherently objective, flawless, and smarter than traditional software. Because of this blind trust, auditors and risk managers must apply what we call professional skepticism. Professional skepticism simply means bringing a questioning mind and a critical assessment to the evidence, rather than taking things at face value. Think of it like using a car navigation system. Just because the digital voice confidently tells you to turn right, you do not blindly steer your car into a lake. You still have to look through the windshield and verify the road is actually there. We must treat artificial intelligence outputs with that same level of healthy caution. Now let us break down the threat landscape. The artificial intelligence threat landscape is vast and involves many different actors trying to exploit these highly powerful computing systems. Their ultimate goal is usually to abuse the technology itself or use it as a weapon to harm people, organizations, or the broader environment. We categorize these threat actors into four main groups. First, we have insider threats. These are an organization's own employees who cause harm, either on purpose or completely by accident. An accident might be an employee pasting highly confidential client data into a public chatbot to format an email faster. An intentional act would be an employee using an internal artificial intelligence tool to siphon off sensitive financial records to sell them. Think of insider threats like a trusted chef in a restaurant. They might accidentally leave the secret recipe on a park bench, or they might deliberately steal it to start a competing business. Second, we look at nation-states. These are entire countries using artificial intelligence to advance their global strategies, like conducting cyberespionage, warfare, or extreme surveillance. For instance, a government might use facial recognition to constantly monitor its citizens and suppress their rights. Imagine a massive, invisible, digital border patrol that watches every move a person makes from the sky. Third, we face cybercriminals. These are hackers who use artificial intelligence to upgrade their attacks, making them faster and harder to catch. They might use an algorithm to write perfectly convincing scam emails or to code advanced viruses. This is like a common burglar who suddenly gets their hands on a magical skeleton key that automatically guesses the combination to any lock in the neighborhood. Fourth, we have the artificial intelligence developers themselves. Sometimes, the people building these tools fail to align them with human ethics. A developer might create a biased algorithm that unfairly denies housing loans to specific groups of people. It is similar to a sports referee who was only trained to enforce the rules for one specific team, completely skewing the outcome of the game. Moving on to the risks themselves. It is crucial to understand that artificial intelligence poses both technological and human-related dangers. Identifying these risks is famously difficult because these systems are often a mystery, meaning we cannot easily explain how they arrive at their answers. We have to catch these issues early to limit the damage. The National Institute of Standards and Technology provides a specific framework for the types of harm these systems can cause. They divide harm into three categories. The first category is harm to people. This can be on an individual level, like threatening a person's physical safety or civil liberties. It can be on a group level, like discriminating against a specific demographic. Or it can be societal, like disrupting democratic elections or ruining access to education. To picture this, individual harm is like wrongfully confiscating someone's public transit pass. Group harm is refusing to sell transit passes to anyone from a specific neighbourhood. Societal harm is shutting down the entire city's transit grid so no one can commute or vote. The second category is harm to an organisation. This includes disrupting daily business operations, causing massive financial loss through security breaches, or destroying the company's public reputation. Imagine a factory where the machines suddenly stop working, thieves break in to steal the inventory, and the disaster makes front-page news, causing all customers to flee. The third category is harm to an ecosystem. This is massive in scope. It means damaging interconnected global systems, like the global supply chain, the international financial market, or even the planet's natural resources and environment. Think of it like poisoning a major river. The poison kills the fish, which ruins the local fishing industry, which bankrupts the town, which causes a ripple effect across the regional economy. So, how do we measure how risky a system is? According to the framework by the Organisation for Economic Cooperation and Development, there are three primary criteria for determining risk levels. First is scale. Scale looks at how serious the negative impact is and how likely it is to happen. You can think of scale as the difference between getting a paper cut and getting struck by lightning. Second is scope. Scope measures how wide the application reaches, meaning how many individual people will be affected. Think of scope as the difference between a broken coffee maker in a single apartment versus a complete power outage across an entire major city. Third is optionality. Optionality evaluates whether people actually have a choice to interact with the artificial intelligence or if its effects are forced upon them. Optionality is like the difference between choosing to buy a ticket to ride a roller coaster versus being forced to breathe heavily polluted air in your neighbourhood. Furthermore, regulations like the European Union Artificial Intelligence Act categorise these risks into 4 distinct levels to dictate how strictly they should be governed. At the top is unacceptable risk. These are banned entirely, such as dangerous biometric surveillance or social scoring systems. Below that is high risk. Then comes limited risk. Finally, at the bottom is minimal risk. Imagine these levels like modes of transportation. Unacceptable risk is like trying to sell a car with no brakes, which is completely illegal. High risk is like driving a regular car on the highway, which requires a license and strict safety rules. Limited risk is like riding a bicycle, requiring only basic safety gear. Minimal risk is simply going for a walk in the park. To properly identify these risks, we must look at the entire life cycle of an artificial intelligence system and the different people involved at each step. The framework highlights 7 distinct stages and their corresponding actors. First, there is the plan and design stage. Second is the collect and process data stage, handled by data collectors and processors. Third is the build and use model stage, managed by developers and modelers. Fourth is the verify and validate stage. Fifth is the deploy stage, executed by system integrators. Sixth is the operate and monitor stage, overseen by system operators. Finally, the 7th stage is use or impacted by, which involves the end users and stakeholders. You can picture this life cycle just like building a commercial aeroplane. The people mining the raw aluminum in the first stage are completely different from the engineers designing the wings later on. Those engineers are different from the test pilots validating the aircraft, who are different from the commercial passengers who are ultimately impacted by the flight. Risk can enter the process at any of these specialized stages. Managing artificial intelligence risk is full of unique challenges. Often, the people tasked with managing risk are not actually experts in artificial intelligence. This creates a dangerous knowledge gap. To fix this, organizations must build a strong governance structure that forces developers, risk professionals, and auditors to talk to each other and collaborate. Let us carefully walk through the 6 specific challenges for risk management in this field. Challenge number 1 is third-party solutions. When you buy a system from an outside vendor, you inherit all of their problems, including flaws in their software and toxic data they may have used. It is exactly like buying a pre-baked cake from a stranger. You have no way of knowing if the baker used expired milk or contaminated sugar until it is too late. Challenge number 2 is the artificial intelligence lifecycle. Risks change dramatically depending on what stage of life the system is in. A model in the design phase looks very different from a model running live on the internet. Think of a puppy. When it is small, it is harmless. But if it grows into a massive, poorly trained guard dog, the level of risk to your visitors changes completely. Challenge number 3 is the availability of reliable metrics. Right now, the industry cannot agree on how to properly measure if a system is trustworthy. Because of this, developers often invent their own scorecards, which naturally favour their own interests. Furthermore, developers cannot foresee every crazy way a user might try to utilise their tool. Letting developers choose their own risk metrics is like allowing a student to write, take, and then grade their own final exam. Challenge number 4 is the real-world setting. Testing an algorithm in a safe, controlled laboratory does not expose it to the chaos of reality. Building a sturdy model boat and testing it in a calm swimming pool proves nothing about how that same boat will survive a violent hurricane in the open ocean. Challenge number 5 is inscrutability. Inscrutability simply means something is impossible to understand or interpret. These advanced models lack explainability, creating massive uncertainty. Imagine having an incredibly smart magic 8-ball sitting on your desk. It gives you brilliant answers to your business problems, but it is welded shut. You can never open it up to see how the gears and dice inside are actually making those decisions. Challenge number 6 is the human baseline. Many of these tools are built to replace or assist human workers. However, to prove a machine is better or safer, you need a baseline measurement of how well a human does the job. You cannot genuinely claim that a new robotic street sweeper is faster and safer than a human worker if you have never bothered to record how long it takes a human to sweep that exact same street. Let us quickly recap everything we have covered today. We explored the critical need for professional skepticism. We reviewed the 4 types of threat actors: insiders, nation-states, cybercriminals, and developers. We broke down the categories of harm affecting people, organizations, and ecosystems. We examined the risk criteria of scale, scope, and optionality, along with regulatory classifications. We mapped out the 7 actors across the technology lifecycle. Finally, we unpacked the 6 major challenges of managing these risks, from third-party vendor blind spots to the inscrutability of the algorithms. Excellent work today. To ensure you are fully prepared for your exam, please remember that all the important topics and concepts from this session are covered in the multiple choice questions on rucloud.com. You should ideally solve the chapter-wise questions there to reinforce your learning before you move on to the next session. Keep up the great momentum, and I will see you in the next lesson.